Hello class, this is a video tutorial on combining transformations part 3. In this video we'll be looking at applying transformations to just the graphs. And these transformations can be applied without even knowing what the equation of the graph or the function might be. So let's get straight into our first set of examples. So we're going to be given the graph of f of x. We don't know what this equation is. And all we need to do now is just apply these transformations. As we've seen in the previous lesson, it's best to recognize what transformations are actually happening first. So without doing the order of these, I'm sure a lot of you can find that the transformation of this x plus 1, that is a translation 3 units to the left. So 3L, that's the first one. And this negative y, if you can remember how this got here, it would have, because remember initially the function would have been y equals f of x. How does the negative f of x suddenly appear? Well, remember we can only substitute x and y. You can't multiply negative f of x. But we know that we can make negative y equals f of x. When y becomes negative y, that is a vertical reflection or a reflection on the y-axis. So reflection on the on the x-axis. Okay, so we're reflecting along this axis because these y values become negative y values. Now consider the order in which these happen. You can recall from the previous video, since this is a left and right transformation and this other one is an up and down transformation, the order of this won't matter because it is commutative if you have two different transformations, one going left and right, the other one going up and down. So the order of these won't matter. And I'll demonstrate to you in this first example for commutative properties of this. So let's translate this whole thing. 3 units, sorry, I don't know why I keep doing 3. It's 1 unit to the left, 1 there. So moving this 1 unit to the left, let's look at the critical points here. This point, don't know the coordinates, but using the block, 1 unit left would be this one. This point here, 1 unit left, would be here. This turning point of this cup is moving 1 unit to the left. This point here, 1 unit to the left. And this point here will also be 1 unit to the left. So currently, without drawing this in, our function should look something like this. That is our translation, 1 unit to the left. But now we're going to reflect everything along the x-axis. So, very slowly here, this point reflected on the x-axis will become, well, this point. This point reflected along the x-axis will be reflected to here. Since this point is on the x-axis, it doesn't move, so that stays where it is. This point reflected on the x-axis is here. And this point reflected on the x-axis, since it is 1, 2, 3, 4 units above, it is now going to be 4 units below. 1, 2, 3, 4. So I hope you can imagine now what this looks like. It would be something like so. Now that there is a translation first and then the reflection. But look at what happens if we reflect this first and then we translate it. So reflecting all of these points first, this point reflected goes here. Let's go a little bit faster. This point reflected doesn't move. This point reflected goes to here. And this point reflected goes up here. This point reflected along the x-axis goes to 4 units. 1, 2, 3, 4. It goes here. Now that we have that, you can see the current position of this first reflection. Should be something like this. But now if we then move this to the left 1 unit, you can see that it actually is no different had we reflected it first and then, had we translated it first and then reflected. Let's go back to my neater version. There we go. Okay, so let's move on to this next one. Again, let's first identify the transformations that are happening. X, because remember the original is always going to be y equals f of x. For the x to become x plus 1, it has been substituted by x minus 1. So that is 1 unit to the right. Sorry, that's a translate. 1 unit to the right. And this plus 2, remember, doesn't appear unless it has been substituted for x. But this has come from y minus 2 equals f of x. So that means that was a translation 1 unit, well, 2 units up. It's a translation 2 units up. Now, remember, these are 2 translations, so the order of this won't matter. So just to show you, with just 1 point, this point, if we translate 1 unit up, across, and then 2 units up, it's no different if we move it 2 units up and then 1 unit across. So using just those critical points, so the first one here, this one, 1 unit right, 2 units up. Done with that one. Same with this, 1 unit across, 2 units up. This point as well, 1 unit across, 2 units up. This point, 1 unit across to the right, 2 units up. And this point as well, I'm sure you get the idea, just taking all of these critical points, 1 unit across, 2 units up. And this point here, also 1 unit across, 2 units up. I hope you can imagine what this graph will look like. Straight line here. This parabolic curve going down like this. There's a downward, well, concave up parabola shape looking thing. Let's just draw that. And then a straight line going up like so. And that there is our transformed function of that graph. Okay, so I hope that gave you an insight into how we can apply these transformations, and always keeping in mind the order of these things happening, because as you've seen previously, the order of these transformations do indeed matter. Hope to see you in the next video where we tackle more examples. Hope to see you then, and best of luck.